Hello again. So for those who are here quite often, you probably know that's the third week of me talking to you, so you're probably quite bored already. But yeah, today's topic is Galaxies. Thanks, Holly, for the introduction. To give you a short few information before we start, I'm the person with the least knowledge on galaxies, but I really enjoy them through the course that I've been doing this year. So hopefully I'll give you a quick, all the basic stuff that you need to know. Feel free to ask questions, feel free to interact with me during the presentation. I'm more than happy to see hands up. So yeah, let's begin. So first of all, what is a galaxy? Does anyone have any ideas, something that they might want to share? I'm not an examiner, there is no wrong answer, so feel free to just say whatever you like. Any ideas?
A lot of gas.
Lots of gas, yeah, indeed, that's one. What about something else, something that is very shiny and we see in the night sky?
Stars.
Stars, yeah. So basically, a galaxy is a massive system of stars, dust, gas, and a lot of dark matter, which is something that we cannot physically see, but we know it exists. Galaxies contain billions and billions and trillions of stars, which is quite a lot, you know. So, yeah, they come in different shapes and in different types. There are 3 main types and then 2 subtypes. Correct me, professors, if I'm wrong. So the main types are the spiral galaxies, the elliptical galaxies, and the irregular galaxies. And then we have the lenticular galaxies and then the peculiar galaxies. But those are not, they're not fancy. So we just focus on those 3, okay? Yeah, most of them have a supermassive black hole in the middle. So don't go near that area if you ever get the chance of space travel. They are very wide if you see them face on, so they are 100,000 light years wide, which means that if you had the chance to travel from one side to the other, traveling with the speed of light, it would take you an eternity to get there eventually. So they're absolutely huge. They can in fact merge and collide with each other and either form bigger galaxies or change shape, change perhaps type. That's something that scientists are really working on to see if there is an evolutionary stage between mergers of galaxies and things like that. They can group together, so they find bodies and they can form groups and clusters. We see galaxies as they are many years in the past, because light, as you know, it takes time to reach Earth. So no matter how much we investigate them, we will never see them as they are at this time that we see them. So for light to travel to Earth, it takes many years. So we actually see how they look like in the past. Okay, and then obviously there are more galaxies in the universe than the grains of sand that exist on Earth, which is very scary and very amazing at the same time. So yeah, I hope you don't get any crisis of your existence hearing about this. So this is how our galaxy looks like. I'm sure all of you are familiar that our galaxy is the Milky Way. The Sun is approximately in the halfway between the center of the galaxy and the edge of our galaxy. By the way, can anyone guess what type of galaxy is that? Spiral, well done. Yeah, spiral galaxies consist of a massive bulge in the middle, which is where the supermassive black hole is. There is the disk and the spiral arms, where all the stars and dust and gas is there. There is a halo which surrounds the galaxy. As you can see, if you see the galaxy edge on, it's much thinner, and then there is this halo that surrounds it. And then basically on that area, you can find the globular clusters. So a little bit more details about our own galaxy, which is the Milky Way. It is in fact a barred spiral galaxy, so it doesn't look like it if you see the image below. So the bar is not very clear, but you can see it in the middle. It has a central bar, as we said, and then it has the spiral arms that extend outwards, and it is where mostly newly formed stars exist there. So it contains around between 100,000 to 100 to 400 billion stars, which is quite a lot. It includes the sun, obviously. And then, so as we said, phase on it's 100,000 light years across, and edge on is only 1,000 light years across, which means it's much, much thinner. So yeah, for those of you who were here last Astronomy on Tap, we talked about the wow signal, which came from Sagittarius A. Sagittarius A is basically the black hole that exists in the center of the galaxy. And it is massive. It has a mass of 4 million times the mass of the Sun. So yeah. Then our Milky Way is part of a local group, which is called the neighborhood, and consists of approximately 50 galaxies, which includes the Andromeda. And fun fact, we are on collision course with Andromeda, so eventually after a billion of years, we will merge with Andromeda, and apparently scientists will call this the Milkomeda. Good name, right? So yeah, as we said earlier, we live on the suburbs, so imagine if we could compare our galaxy with the Milky Way and with Cardiff, not Milky Way, someone could say our sun is probably in the Cardiff Bay area, not in the central region, the black hole region, where it's pretty much central. All the bars are there, all the crazy people and drunk people. So there are 3 main galaxy types, as we said earlier. Oh yeah, question. Yes, sorry.
Is our position in the suburbs what makes Earth habitable?
Can you repeat that, please?
Is where we are, like in the suburbs, what makes Earth habitable? Like, is it?
Not quite. So that has to do with where the Earth is located in terms of the solar system itself. So galaxies will not affect habitability, but how far the planet is from the Sun, that is what affects habitability. Yeah? So there are 3 main types. There are, of course, the spiral galaxies. You can see some different types there. As you can see, the bottom right image, this is a barred spiral. The bar is much more clear compared to other spiral galaxies. They are well structured and they have this nice distinct shape that you can see there. They appear to be much bluer in color, which for astronomy and astrophysics, this means that there are new stars that constantly form. So when we see something blue while investigating a galaxy, it means that the star formation rate, or SFR, as you see over there, is very high. Okay? And then the key characteristics are obviously the nucleus, which is the black hole in the center of the galaxy. There is the galactic bulge, which is the very dense central region. So imagine the bulge has probably the highest proportion of stars in the galaxy. There are the spiral arms, the galactic disk. There is a bar. Sometimes it's very easy to distinguish it, sometimes it's not. Some spirals don't have at all. Then there is a galactic and dark matter halo, as we discussed. It surrounds the galaxy itself. And then there are the globular clusters as well. Then we have the second group, which is the elliptical galaxies, which is much more meh, because it's just a sphere. And they appear to be much more redder in color, which means that they have much older population of stars. So the stars are much, much older than the spirals, and this implies that there is not ongoing star formation in elliptical galaxies. And this can be very important when we investigate the early universe. So if we find some very, very old elliptical galaxies, we can predict the conditions a few years after the Big Bang, essentially. So that's why they're very, very important. And they have much less parts. So they have the galactic nucleus, the core. They have the bulge, which is very bright, just like the spirals. They have the galactic halo, the dark matter halo, and they also have the globular clusters. And then finally, we have the irregular galaxies, which are the most fun because they have crazy shapes, they're chaotic, and yeah, they have essentially patches of dust and gas, which can be very interesting because there could be regions that star formation happens and some regions that no star formation takes place. So we have the stellar regions, as we said, the star forming regions, the gas and dust clouds, so they could be just a cloud, a massive cloud, that could actually hide the central nucleus of the regular galaxy, or just some of them might not have them. This could be a case as well. And then there is also a dark matter halo as well. This is what we call the Hubble fork. It doesn't show any evolution of the galaxies, it is just there to show the differentiation of the galaxies. So as you can see on the left-hand side, we have the elliptical galaxies. That little thing, the S0, that's what we call the lenticular galaxies. So some people might think it's a type of an elliptical galaxy, some others differentiate it that way. It's a bit more distant, more specific, so it's a thing on their own. And then we have the normal spiral and the barred spirals, which they are also divided into subgroups, so this fork can extend it even further, but it gets much more complicated as scientists study it. So, some galactic fun facts, let's say. So, galaxies actually have a lot in common with Tinder, surprising. So they are looking extremely nice and beautiful as we see them. They have different shapes and sizes, but folks, we don't know how they look like in reality. Which it might be problematic for your date, not for the galaxies. I mean, you can't go wrong with astrophysics, right? So as we said, Andromeda and Milky Way is about to merge. But this will happen in 4 billion years, so that gives us plenty of time to panic slowly. And then obviously the black hole that is in the middle of the galaxies is like the bouncers in the center of Cardiff. They're very dense, very massive, and very scary at the same time. So now I've got a selection of some interesting galaxies that they might look nice to you, and at least they look nice to us as physicists. So the first one is the jellyfish galaxy, which is a type of spiral galaxy with a bar. But what's interesting about it is that there is essentially stars that drift outside of the spiral arms, and it creates this nice little effect, making it look like a jellyfish, which is very cute. Then we have the zombie galaxy, which is also very interesting. It might not look interesting, but it is because it hasn't made any stars for billions of years, and it makes it extremely old. And this could mean that it existed a few years after the Big Bang. So, yeah, it is not active, no star formation going on, but still very bright. So we can study it. What type of galaxy do you think that is? Can someone think of the 3 types? Does it look like a spiral? I don't know, astrophysicists, any idea? You probably don't. I would say it's an elliptical, but... Is it a spiral? Okay, I'll go with astrophysicists. I told you I'm not the expert here, so I won't say anything further. Then there is the Tadpole galaxy, which is, what's interesting about it is that it's huge. So in total it's 10 times the Milky Way, and then it has a very, very long tail, which is 5 times the Milky Way. And essentially this huge thing swims across space, which can be scary, right? Imagine coming across this. Then we have the luminous diff, which is essentially what the name says. So it is a galaxy in the middle, and then you can see there is one galaxy there, one there, one there, and essentially what it does, it steals the dust and gas of those galaxies, and therefore it steals the luminosity of those galaxies as well. Which is one of those that I really like, this one. Then we have the cosmic vermin, which is this is an actual picture. It's not it was taken from the Hubble telescope. And yeah, it is very interesting. You can go search more information on your own if you feel interested about it. I would say that's probably either an elliptical or a lenticular galaxy. So yeah, then we have the eye, which is essentially two spiral galaxies, probably about to merge. You can see the one on the right and one on the left. This one is very nice as well. And then finally we have a galaxy that we mentioned in the quiz. So spoilers, that's one of the answers. We have the Sombrero galaxy. So that's how it looks. This is definitely a lenticular galaxy. So it has a huge central bulge in the middle, and then it has this cloud of dust and gas around it. And if you see it edge on, it actually might not be as visible as if you would see it face on, because of the massive cloud in the middle. So that was it for today. If you have any questions, yes?
Are elliptical and irregular galaxies kind of flat, the same as spiral galaxies?
Yes, so in terms of, if you see them, it has to do with the perspective that we see them while we investigate them as well. Obviously, some galaxies we see them face on, which they always look, if it's a spiral, we see the spiral arms. If it's an elliptical, we see just the bulge. If you see them edge on, normally the bulge is a bit, thicker than compared to the spiral arms, or if it's a lenticular galaxy, to this dust cloud. So if you would see an elliptical kind of edge on, you would still see a bit of, like a little sphere, let's say. So, yeah. Yes?
Why are galaxies and solar systems so flat?
Why are galaxies in?
Why are they so flat?
Good question. I think they have to do with the rotation around the central black hole. Am I correct, professors? So I know for spirals there is a very complicated physics going on with the spiral arms, because imagine, of course, stars go around, they don't stay in the same place, they rotate around the central region of the galaxy. And in fact, there is a very complicated physics going on, because if it was continuing to spiral around the central bulge, we would eventually get a massive kind of, like a snail pattern, I would say. I don't know how to totally explain it. So it's kind of like a wave. It spirals, and then essentially the parts don't go further down, they kind of move along, if that makes sense. That's why the spiral arms remain in position and they don't become much longer, and eventually having one massive spiral arm, if that makes sense. Did that kind of help you? Yeah? It has to do with the rotation around the center of the galaxy. Yes?
You said the eye galaxies are
Two
about to merge. Is that galactic about? Is that like in the next 100 billion years?
Well,
or is it like we might see it?
Well, normally it takes a lot of years to happen. Because imagine this thing could be 100,000 light years wide, which is quite huge. And they, even if galaxies move at very, very high speeds, but we're talking about huge distances, so it's unlikely for us to see it. I don't know if there has been any merging of galaxies that we have seen in the past.
It's like 5 billion years away.
Okay, yeah. So it's very, very difficult to see. But yeah. Yes.
So we know the end of the galaxies converge in the local
Yes.
region. What about the other galaxies in the local region? When they eventually merge or they move away?
Well, so we know that the universe expands, and we know that almost everything goes away from us. It's just that Andromeda has this kind of trajectory to Earth's Milky Way. It's not that it is attracted to something, it's not that it is directly linked with our Milky Way, it's just that it has this direction. Our Milky Way has the opposite, so they kind of will meet in the middle. But yeah, that's kind of what's happening with Andromeda. Yeah. Any other questions? No? Thank you very much. Oh, yeah, one more? when they merge. So we have observed mergings of black holes. So this can happen, and it is a field in physics which is called gravitational waves. So essentially, what happens when two black holes merge? They combine kind of their mass. So imagine if you have a 30 solar masses black hole and a 20 solar masses black hole. The new black hole would be approximately a little less than 50 solar masses, pretty much. So it's kind of, you have, it is like combining two snowballs together, kind of you get a bigger one. So this is exactly what happens. The black hole immediately becomes much larger. Yeah. Cool. Thank you very much, and I hope you enjoyed it.